Let's look at homework exercise number 14 from section 6.2, part 2. Number 14 states a nurse must administer 160 micrograms of atropine sulfate. The drug is available in a solution. The concentration form is 500 micrograms per milliliter. How many milliliters should be given? Now, the two values here that are in proportion are micrograms and then per milliliter. Now, per milliliter, no value is given, so it just means 1. So, micrograms over milliliters. Okay, what do we know? There are 500 micrograms for every 1 milliliter. They need to administer 160 micrograms, which is in the numerator, and so the how many milliliters we don't know, so we'll use X to represent our milliliters. Okay, that's the unknown. Cross products to solve for X. Take the cross products. 500 times X is equal to 160 times 1. Divide both sides by 500. And the 500 divided by 500 is 1. 1 times X is just X. 160 times 1 is 160 divided by 500. So we'll do that last step on our calculator. Take 160, divide by 500. And we get 0.32 milliliters. All right. Whenever it says whenever it doesn't have a round off or anything, just put in all the decimals. All right. Let's look at problem number 15. Assume that the stopping distance of a van varies directly as the square of the speed. Now, okay, this one can be set up a proportion, but it is what? The stopping distance, and it's the square of the speed. So distance is in the numerator, we can put that, and the speed is in the denominator, if we put, as long as we're consistent, but it's squared. Okay, or we could put speed squared over distance, doesn't matter, just as long as you're consistent. Now notice, 40 miles per hour can stop at 40 feet. So the distance is 40, the speed in miles per hour was 40, but it's squared. If the van is traveling 52 miles per hour, so 52 is the speed, that's in the denominator, but it's squared, right? It's to the second power. What is the stopping distance? That's the unknown, so we use our variable X. So again, to solve for X, cross products are equal 40 squared times X is equal to 40 times 52 squared, that cross product, divide by 40 squared, right? You can just put in the squares in your calculator, or you can put in the values themselves, right? You can square them, use the values. But anyway, so our answer, so when we solve, when we go ahead and divide by 40 squared, so these will be 1, then X will just equal that quantity right there, right? 40 times 52 squared divided by 40 squared. Now, again, you can just put that, and you can use the square key on your calculator. You don't have to figure what it is. You can just do it all doing squares. So you can go ahead and put that in. So what was it? It's 40 times 52, and 52 was squared, all right, divided by 40 in the denominator, but that was squared, that was a speed, and so we get 67.6. Type an integer or a decimal, so again, just don't round off at all, put in the whole number, 67.6, and there's our answer. Now again, you could have done 52 squared, which is that number, 2,704, 40 squared, which is that number. So then you would get what? You would get 40, it would be 40 times 52 squared, which is 2704 if you did that value, and then divided by 40 squared, which is 1600. And there's your exact same answer, 67.6. So what I'm saying there is you could have multiplied it out first. You could have had the stopping is 40, the speed is 40 squared, and then the stopping is we don't know, and the speed is 52 squared. So 40 squared was 1600, and 52 squared I think was 2704. So then you can just do the cross products. 1600 times x equals 40 times 2704, and divide both sides by 1600. So you get x equals that quantity right there, 40 times 2704 divided by 1600, which is right there what we did on our calculator and got it. Okay, this concludes all the problems from section 6.2, part 2. If you have any questions, send me an email at tsquares@motors.edu, TSWIERSZ, or call me at 239-938-7805. Thank you.